Let's take a quick look at some final few topics in this chapter on basic inheritance. So destructors in derived classes. If a base class destructor functions correctly, it's very easy to write the derived class destructor. When the derived class destructor is invoked, it automatically calls the base class destructor, so there's no need for an explicit call. So first of all, in these examples that we've been looking at, we actually don't even need these destructors, but if you were to take a look in the method body of the destructors, there's not much you need to do. If you have a destructor, this is fine. This is good enough for this particular class. The default, it's as if you have an implicit call to employee. And this, I don't know if it'll work, which you might actually be able to get this to compile, but you don't want to do this. This is put in there by default. Let's just check and make sure that it doesn't compile. So there is implicitly something like this. If I get the syntax right. Okay. This might actually compile, but even if it does, you should not do this. No matching function call. Okay, so just pretend that there is something like this. You should never do it, and in this case, you actually can't even do it. Okay. So that's what is meant by saying that you don't have to call. So there's no need for an explicit call to the destructor. You never actually call the destructor anyway. You shouldn't. So derived class destructors need only be concerned with derived class variables. The base class destructor will take care of base class variables. So any data that you point to, any dynamic objects, dynamically allocated memory. Base class destructor will handle all the inherited data automatically. So if there were something in employee that needs to be cleaned up, let's say for whatever reason we put in a destructor. Oh yeah, we don't have one here, that's why it wouldn't work. So let's try that again, and we'll say virtual, which is always a good thing to do. Employee, and we'll see what virtual means the next chapter. So let's say we do this. That's all. We don't have any dynamically allocated objects, so this is good. Save it. Compile this. And once we have an explicit destructor, and I believe we can do this. Let's just try it. It's worth looking at. Okay. Nope, still cannot do it. All right, that's good to know. Okay. So you take care of all, if you have dynamically allocated memory here, you take care of it here. It will, by default, you shouldn't put it in, because as we saw, we got an error message. By default, it will call the destructor of the base class. Okay, so, and you don't have to worry about the base class object. How are things called? Let's say we have three classes. Class A is the base class, class B is the derived class from A, and class C derives from class B. So B inherits from A, C inherits from B. If you have an object of class B that goes out of scope, the first destructor that's called is the destructor of class C. Sort of the opposite of how constructors are called. When you create a class C object, you create the A part of C first, you create the B part of C, and then you do the things in the constructor of C itself. When you destroy, you do the opposite. You call the destructor of C first, and then implicitly, you don't have to do it, right? And you saw we get an error message if we try to. The destructor of B is called, and then finally the destructor of A is called. So that's how destructors work. And in the example in this chapter, actually there was no need for a destructor or a copy constructor or an assignment overload operator, any of those. Okay, so remember from Java, you have is-a relationship versus has-a. Is-a is the same as inheritance. Has-a, in Java, we called it composition. The book, I don't think, doesn't use that term, but that's the term that we used when we learned Java. So inheritance is considered an is-a relationship, that is, an hourly employee object is a employee, and employee object too. And if the book goes over some other examples, if you have automobiles and convertibles, and a convertible is an automobile, but not all automobiles are convertible. And similarly, not all employee objects are hourly employee objects. So you can use an hourly employee object where you need an employee object, but not the other way around. Okay, so that's the same as in Java. A class can contain objects of another class as member data, and that's called composition, also called has-a relationship. So for example, employee has a string object, that is a name, and another string object for a social security number. Okay, so in addition to public inheritance, which we will use, there is also protected and private inheritance. This is rarely used. Protected inheritance, what it does is all of the things in the base class that are public become protected in the derived class. So it sort of increases your security, increases the protection of your data members. Now you can also do private inheritance, where everything in the base class now becomes private data members in the subclass or derived class. So if you had a public data member in employee, of course, remember there's no good reason to make anything public, but if you did in this derived class, it's as if you made them private. Okay, so they're in this class, but if you use private inheritance, everything in here becomes private in the derived class. Now C++ does give the programmer the opportunity to use multiple inheritance. That is, you can set up a derived class that can have more than one base class. Now this, if you remember, is not possible in Java. In Java you have very limited multiple inheritance, and I think that was a good design principle to use in Java. I think the designers of Java actually did the right thing, because this is, as is written here, the possibilities for ambiguity are endless. I don't want to even start looking at some examples, but there are many cases, and the book goes over some of them. If you have a class that inherits from two classes, and let's say those two classes maybe inherit from one ancestor class, then there's all kinds of problems that could show, that we could run into. So this is multiple inheritance in general is a dangerous undertaking. There's a lot of programmers who believe it should never be used under any circumstances. Certainly, I would say this should only be used by experienced programmers. We won't use this at all in this course. But if you did want to use it, here's how you would set it up. You would say some class, and you would use colon for inheritance, and you would say public, and then just list the classes one after another followed by commas. So this is very similar to Java implements. Remember, Java has limited multiple inheritance in the sense that you can only extend one class. One class can extend another class, but only one class. But you can implement any number of interfaces. So interfaces are very simple, very limited. They're not as general as classes. So in that way, Java sort of does have multiple inheritance, but it's very limited multiple inheritance. Okay, so that's it for inheritance. We will use inheritance for the rest of the semester. Make sure that you understand some of these basic ideas and these very last things. Multiple inheritance, don't worry about it. But remember what public inheritance is. Is-a versus has-a, you should know from using it in Java, same deal. Destructors are very important. Now the example that was used in the book for this chapter was sort of made it so that you did not really need a destructor, but in the future in this course we will actually need to set up a lot of dynamically allocated objects, and so we will need destructors that actually do things. And so you have to keep these things in mind that we learned in this chapter. How do destructors work in the context of inheritance, things like that.